Welcome back. In this part, we'll start writing the actual smart contracts by implementing the facets and then connecting everything through the main contract. So this is where the diamond architecture really comes to life. So let's jump right in. Create a folder in our contract and let's name that folder as facet. And in facet, we'll create a file naming it as DiamondCutFacet.sol. So this is a facet that has allow contract owner to add, replace, or remove functions in the Diamond contract. So it will implement the core upgrade logic that's defined by EIP-2535. That's a Diamond standard. And like only the owner can execute this upgrade. So let's just go on writing it. So first we'll specify our license. So SPDX license identifier. Then we'll go on importing. So we'll first import diamond cut. So I will be importing this diamond cut from. So we have written it in interfaces, right? So we'll take it from there. So interfaces slash the name of the file that we have written. So this will simply import the diamond cut interface, and this will define the standard diamond cut function as per the EIP-2535. Then next we'll be importing our library file. So lib diamond. We have written this file in libraries, right? So I'll take it from there. Libraries slash the name of the file as libdiamond. Now we'll write a contract. So contract will name it as diamond, but facet is diamond cut. So this is the contract that is a facet responsible for modifying the diamond. So it will allow the adding, replacing, and removing function from the diamond. Let's create a function named as diamond cut, and this is the main function that is required by the diamond standard. And we'll give facet cut call data diamond cut. So this is the list of facet changes. Add, replace, remove. Then address in it. That's an optional initialization we do of in contract address. And by call data at the initialization of the function call. Then we'll go for externally overriding it. So external override, and then libdiamond dot enforce is contract owner, libdiamond dot diamond cut. So this libdiamond dot enforce is contract owner will ensure that the only contract owner can modify the diamond, and it will revert if message dot send that is not the owner. And here in this libdiamond dot diamond cut, and we'll give inside this will have diamond cut in it and the call data. So this applies the diamond cut. First is the changes that we do, add, replace, remove, and second it will optionally execute the initialization logic via the delegatecall. So that's it. This was our first facet, that's DiamondCutFacet.sol, which was responsible for upgrading the diamond contract. It also implements the diamond cut function that's defined already in the diamond standard. Only the contract owner is allowed to perform these upgrades, ensuring there is a high security. And it also supports the optional initialization logic after the upgrade. So this facet forms the core of the diamond's upgradability mechanism. And the second file that we'll be writing in our facet is the DiamondLoupeFacet.sol. So this facet which we'll be writing here will be providing read-only inspection function for the diamond. It will allow the users and tools to see all the facets, their functions, selectors, mappings, everything. Let's begin. Then we'll go on importing. So now we'll be importing the library first with Diamond, and we'll be doing this where we have kept it. So we have kept it in the library slash, I'll give the name the diamond.soul. Then we'll be importing our diamond loop. So import, and we'll be doing this from, we have kept this in interfaces. So interfaces and the name that we have given to this file. Then the last one I will be importing, same from the interfaces only. We'll be importing I-165. So this we have written in it in interfaces only. So IRC165.source. So this import is done. Now contract, and let's name it as Diamond Loop Fast is I Diamond Loop and the IRC. So this will be allowing tools, explorers, and UIs to inspect the diamond structure. And this Diamond Loop Faucet will be providing an introspection, that's a read-only functionality. Now in this, we'll give a function and name it as facets. This will be external view override returns the facet memory facet, then the libdiamond.diamond storage. Yes, this would be equal to libdiamond.diamond storage. So this is to load the diamond storage using the libdiamond. Now we'll declare event256 as a num facet. This would be equal to ds.facet addresses dot len. So we get the total number of facet addresses. Then facet, that's equal to a new facet and the num facet. So this will create an array of facet stuffs in a memory. I will give for loop and we'll just go on initializing the things, giving a condition that this has to be less than the num facets, and then we'll go on incrementing it. Then the address, so address of facet address, that's equal to ds dot facet addresses. So this loop will take us through each facet addresses. This will just get the facet address, and then I dot the facet address. This will be equal to, this will assign the facet address to the facet struct. Then facet dot function selectors equal to the ds dot facet function selectors, facet function selectors, and the facet function selector function, facet function selector, and then we'll give the address of the facet. And then external view override returns, and then we'll have the bytes for memory function selectors. So this is a function which will return all the function selectors that are supported by a specific facet. Now we'll just load the diamond storage. So let diamond dot diamond storage at storage ds equal to let diamond dot diamond storage. Now function selectors is equal to ds dot facet function selectors. This will fetch and return the function selectors for like it will fetch and return. Now we'll create another function and name it as facet addresses, facet addresses, external view override returns address memory facet address, facet addresses. So this is the function that will return all the facet addresses used by the diamond. Now in this, again, we'll be giving this thing for storing the lib diamond. So for lib diamond storage, then to return the array of facet addresses, we'll give facet addresses that would be equal to ds.facet. This will help to return the array of facet addresses. Then another function, and we'll name it as facet addresses, just facet address. So the difference is this is the one that will return the facet address that implements the given function selector. So there will be a particular return of that address. Here in function facet addresses, all of the facet addresses used by Diamond are returned. So bytes function selector, then external view returns, view override returns the address of the facet address. Then in this storage, and then we'll look up and return the facet address for the given selector. So facet address would be equal to ds.selector to facet and position. Then the function selector dot the facet address. So this was the function. Last function that we'll be giving is the function support interface. Function supports interface. So this is ERC-165 support. So this function is to indicate whether the Diamond supports a given interface or not by store. So this will be required for ERC-165 compliance. And we'll give the bool as it will check whether it supports a given interface or not. So for true false, we'll give the bool. Then we'll give our Diamond storage, and then returning ds dot supported interfaces, and the interface ID. So that's it. That was all about our DiamondLoupeFacet.sol. So this facet provides read-only introspection capabilities for the Diamond contract. It allows to view all the facet addresses and their function selected, all the function selectors. So developers and tools can use it to understand how functions are distributed across facets. So it also supports the ERC-165 for interface detection. Now, the other one that we'll be creating in facets only. So we'll create a file and name it as OwnershipFacet.sol. So this is the facet that will manage the ownership of the Diamond contract, allowing the current owner to transfer ownership to a new address. So this ownership is stored centrally using the libdiamond. So we'll go on importing libdiamond as well in this. So first, let's start writing it with our license identifier. So now I'll give the Solidity compiler version. That would be 0.8.0. Then we'll be importing. So import libdiamond, and we'll be importing this from. It is written libraries, so libraries, and the file name as libdiamond.so. So this library which I've written manages all the shared diamond storage and ownership logic. So we'll be requiring it here. Now let's write the contract ownership, and let's name it as OwnershipFacet. OwnershipFacet, and then we'll write the function in it. So this contract OwnershipFacet will handle all the ownership related functionalities for the diamond. So function transfer ownership. So that's named as transfer ownership, and we'll have the address of the new owner in this. We'll take it externally from the contract. So external. Then libdiamond dot enforce is contract owner. So this will ensure that The current contract owner can call this function and it is revert if the message.sender is not the owner. And then lib diamond dot set contract owner and it will set it to new owner. This will update the contract owner in diamond storage to new owner. Then function as owner external view returns and this will give the address of the owner. This will return the current owner of the diamond and then owner is equal to the libdiamond.contract owner. This will fetches the contract, will just fetch the contract owner from the diamond store. Here, and I will just close it. So this was all about our facet contract. So this facet which I have written will manage all the ownership, allowing the current owner to transfer his ownership to a new address securely. And here the access control has been imposed using our diamonds. Enforced is contract owner. Now we'll write the main contract. In contracts, we'll create a file and name it as diamond.soul. So this is the main proxy contract of the diamond standard. We'll just write it. It will forward function calls to facet contracts using delegatecall. So let's begin. Identifier MIT with mass Aditi version will be 0.50. And now here we'll be importing some files. So we'll be importing libdiamond from libraries and name of the file was libdiamond.soul. Then we'll be importing iDiamondCut. iDiamondCut is from the interfaces. So iDiamondCut from interfaces slash the name iDiamondCut.soul. Now I'll write the contract. Let's name it diamond. And now let's create a constructor. Inside this, we'll give the address of the contract owner, then the address of the DiamondCutFacet, address DiamondCutFacet. So let's make it stable, and then we'll just set the owner libdiamond.set contract owner, and then this will have the contract owner. Now iDiamondCut dot facet cut. So memory cut is equal to new iDiamondCut dot facet cut, and this will give 1. Then bytes for memory function selector selectors that will be equal to our new bytes for 1. So this 1 is just because we have created an array to hold a function selector the bytes. Now we'll give function selectors 0, that would be equal to iDiamondCut dot diamondcut dot selector. So this is to assign a selector of diamondcut function to the first slot. Then we'll give cut 0. This would be equal to iDiamondCut dot facet cut. This will define the first facet cut entry describing what changes to be applied. Facet address, that would be DiamondCutFacet. So this would be an address of the facet contract that contains the DiamondCut function. Then the action, that is iDiamondCut dot facet cut action dot add. This will specify that the function should be added to the diamond. Then provide like this is function selectors, that would be function selectors. So this is to provide the list of functions selected to add from this facet. Now we'll give the libdiamond dot diamond cut, lib diamond dot diamond cut, and the address 0, it will display nothing. Then give a fallback external payable. So this will find a facet for a function, this is called, and then execute the function. If the facet is found, and it will just randomly return any value. So lib diamond dot diamond storage, and then by its 32 position, that would be equal to lib diamond dot diamond storage position. Then we'll get the diamond storage from here. Now we'll give assembly dot slot, will be the position, then give the address facet is equal to ds dot select or to facet and position, and then message dot ig. This will get the facet from the function selector. Then we'll give a require, and inside it we'll give a condition as the facet should not be equal to address 0. And then the statement that has to be executed, if this is false, then diamond function does not exist. Function does not exist. And again, we'll give assembly, call data copy 0, 0, and the call data size. All data size. So this will copy the function selector and any of the arguments. Then let result. This will be delegate call gas the facet 0, call data size 0, 0. So this will execute function call using the facet. Then return data copy 0, 0, return data size. So it will return any return value or error back to the caller. Now we'll create a switch. So switch result, and we'll give a case 0, and we'll revert 0, the return data size. Then we'll, if this case 0 doesn't work, then we'll give one default case that would return the 0 return data size. And then we'll finally receive the external payable. So this was the main proxy contract of the Diamond standard. It does not contain any business logic, and instead the legits call to facet contracts. During deployment, it will register the DiamondCutFacet to enable any upgrades, the fallback or function, root function calls to the correct facet using selector. So this design allows unlimited and modular upgrades to it. Alright, that brings us to the end of this video. We have successfully implemented the facet contracts and wired them together through the main contract, bringing the Diamond architecture to the life. So in the next part, we'll move on writing the deployment script and the test files to deploy and verify everything works as expected. So see you in the next part. Thank you.